But at least the screen's not cracked. Man, I hope we don't make mustard gas again.
Every single night. I did not go through.
Okay, well, okay, well, there's a crack right there.
For 2 years. To not.
Winner, mustard, please. Hold the gas.
Look, I don't want mine, but my teeth are My teeth are.
All right. So today, ladies and gentlemen, after we go through our Pear Deck, we're going to talk about writing and naming ternary compounds. We have a worksheet that I already put out there for you on ternary ionic compounds, and then we will get into talking about how we can manipulate ternary ionic compounds a little bit with suffixes and prefixes. Okay. Retakes need to be done soon if you want to do one. Probably by the end of the week, maybe next week, Monday at the latest, only because next week, Wednesday or so, we'll be taking our Unit 3 test. 3 weeks from today, ladies and gentlemen, you'll be taking your final exam. Final exam starts 3 weeks from today. So it's coming down to the wire, and it's coming down quickly. So again, if you are missing things, if you want to do retakes, again, you better get to work on them. I am not staying after school on Friday. That is the one day I will not stay, okay? So if you want to do a retake, you need to bring me your test with all your corrections on it, and then we can do a retake. I have them ready to go, but you need to do that first, okay? Questions? Yes, sir.
You take your retake, and what is the full amount of points you can get?
You can get up to a 75%. So your grade will improve. But now remember, you got to be under a 60, in the 60s or less. So if you were in the 70s, 80s, 90s already, you can't do it. Okay. By the way, I still am missing one of my calculators. If it is not returned by end of the day Tuesday, I will put the calculators away. You will need to bring your own 2 classes. Okay. So again, I believe that someone accidentally took it one time, and they might have thought that it was theirs because I have one of these that is not mine. But this is the style that I believe is missing because it's not one of the new light blue ones. I have all of those. But please check, just see if you accidentally took something and you have one that is marked room 214, and then we can give it back. All right, ladies and gentlemen, so here we go. NaOH, binary or ternary, Caden? How do you know? 3 things, okay? How do you know it has 3 things when you look at it? 3 capital letters, perfect. When you are looking at a formula, ladies and gentlemen, if it has 3 uppercase letters, 3 capital letters, there has to be a binary ionic compound in there somewhere. This one has hydroxide in it, ladies and gentlemen, OH. Okay? Aluminum chlorate, binary or ternary compound, Michaela? How do you know by looking at a formula now? Or I'm sorry, by looking at a name. My bad, sorry.
It ends in ATE.
Thank you. If your formula ends in ATE, it is for sure ternary and turn your periodic table over. Now, it can end in an IDE and still be ternary. Then we need to look a little bit closer at it. But if it ends in ATE, if it ends in something other than IDE, it is going to be ternary for sure. So that is a ternary compound, ladies and gentlemen. All right, MgCl. What do you think, Isaiah? MgCl2.
Ternary compound?
Why? Okay, be careful. That is a C and a lowercase l, not a C and an I. Yes, very good. You got to be careful with that. I know years ago, they used to always put the lines on the bottom and the top of a capital I. You could tell it very easily different from a lowercase l. Most fonts don't do that anymore, okay? But I will never give you anything with carbon and iodine in it as a compound, just so you know, as the last 2, unless that's the only 2 things involved, okay? All right, ammonium fluoride. Ammonium fluoride, Declan, ionic or covalent or let me try this again. Binary or ternary?
Binary.
No. Ammonium. Find me ammonium on the front side of your periodic table.
Threw me off with the aluminum.
I know, this one was supposed to throw you off. Okay? I did correct it though. I did not say aluminum. See, this is the point where you should have your periodic tables out on your desks already, ladies and gentlemen. Why? Because you're going to need them every day during this unit. So let's go, Declan. Come on. Take some paper back, please. If there's extra paper, just leave it on one of the desks behind you, please. Come on, Declan, today. No, I can't. Let's go. You're supposed to have this stuff out. You're supposed to be ready. Can you find ammonium on the front side of your periodic table?
Probably not.
No, because it is not an element. But when you look on the back side, what's its formula, Declan?
NH41.
Yes, it is the one positive polyatomic ion, ladies and gentlemen. And this compound is going to end with fluoride. IDE ending. Why? Because fluorine is a lone element in the compound. The formula for this is NH4F. Okay? That is the formula for it. It is a ternary compound, but it is the one ternary compound that uses polyatomic that is a cation. So we just have to be careful. Did everybody get a scratch sheet of paper? Yes? Good. All right. FeSO4. FeSO4. Dante. Ternary. Why? 3 capital letters. When we look at a formula, it's fairly easy to tell. Name a little bit tougher. Potassium nitride. Potassium nitride. Okay? What do you think, Andy? Why? Only 2 elements. Nitride is not a polyatomic. Nitride is nitrogen with an IDE ending. So this is potassium K and nitrogen. That would be a binary ionic compound. Again, a little bit more into it when we look at a name that ends in IDE than just automatically knowing. Okay? Questions? All right. The other day, ladies and gentlemen, we ended with this in class. I asked you to write formulas for these. Get with a partner right now and write formulas for these 5. You've got 5 minutes, ladies and gentlemen. Let's go. I will return your quizzes to you tomorrow, ladies and gentlemen. I'm not going to do it today because I have a bunch of people who still need to make it up.
I don't support that.
Again, ladies and gentlemen, I do not recommend doing these on your own, but I need the desk spread out for a quiz I'm giving second out. So if you want to work with somebody, work with them. But you got 5 of these to get done, ladies and gentlemen. So let's get to work. Come on.
I hate second.
Mr. Beard, what is that you're including again?
You're writing formulas for these names. That's what we started on Friday. So these are the names of compounds that are ternary compounds. So write the formulas for them.
But it's like 3.
Why?
I know where the third one is.
Oh, yeah.
No, the third one is
Aluminum's like 5.
Yeah, no, that's what I.
But aren't these ternary?
Yeah, it's like a 3.
But for
No, it's positive 3. Aluminum's positive 3. I looked at the wrong one.
Yeah, I color-coded mine. When I was bored. Aluminum's charge is negative. Why does that seem to me? What am I doing?
No, aluminum's positive.
That one's positive. I don't know.
I don't.
So, yeah, parentheses. The 2 stays there, the 5 stays out.
2? What 2 are you getting?
Lori actually did that.
There is no 2. I don't know where you're getting a 2, but there's no 2.
What's the 2 from?
Where is the 2? We'll just go.
Oh,
Do what
nitrate.
I'm gonna go to lives, bro.
What's hydroxide?
Right at the top of that one sheet right there, the white sheet over there, OH, -1.
Is that
All right, iron 3 chlorate. Iron 3 chlorate. Evan, what is the formula or what is the symbol for iron? Fe, what is its charge? +3. All right, what is the formula for chlorate? ClO3. What is its charge? Mike. Sorry. Hold on. There you go. Sorry about that. So now, ladies and gentlemen, we will do what we had done with our binary compounds. We will do the crisscross method. What that means is I'm going to take this -1 from up here and I'm going to put it down by the Fe. I'm going to take this +3 from up here. I'm going to put it down by the ClO3. So when we do that, ladies and gentlemen, Fe. Now, I don't need to write a 1 by it. We know that I'm going to erase the 1. We never do that. So then I can just leave that as Fe. Now the ClO3, I write that and I leave that alone. But since I'm going to be putting a number by it, what number am I going to be putting by it, Evan? Well, what number are we crisscrossing to put by it? The 3. Because I'm going to be putting a subscript by it, I put it in parentheses, ladies and gentlemen, and then I put a 3 by it. There is your formula. Fe, parentheses, ClO3, close the parentheses, 3. Now, the reason for the 3 here, ladies and gentlemen, is because iron had a +3 charge. Chlorate had a -1. When I balance them off, it takes 3 -1s to balance off the 1 +3. The crisscross method, just like we've been doing before. That is your compound. FeClO3, in parentheses, the ClO3, and then a 3 afterwards. The only time I need parentheses is if I'm putting a subscript by the polyatomic. Questions? Okay. Aluminum nitrate. Jasmine, what is the symbol for aluminum and its charge? So we always begin by writing the symbol for the cation and its charge, Al and a +3. Jasmine, what is the formula for nitrate and its charge? Thank you. So now we are again going to do the crisscross method, ladies and gentlemen. This -1 becomes the subscript by the Al. This +3 becomes the subscript by the NO3. So our formula, Al, NO3, and because I'm going to put a number by it, put it in parentheses, 3. There is your formula for that one, ladies and gentlemen. Questions? We are doing what we did on binary ionic compounds. The only difference is this group gets treated just like an ion of fluorine, chlorine, bromine. However, if we need to put a subscript by it, we put the group in parentheses. We needed to put a subscript by it. That's why we put the parentheses around it here for the 3. Same thing here, ladies and gentlemen. Questions? All right. Lithium, ladies and gentlemen. Lithium borate. Isaiah, what is the symbol for lithium and its charge?
Li and -1, +1, I mean.
Positive 1, thank you. Borate, go ahead, Isaiah. BO3 and a -1. So this -1 going to come down by the Li. This +1 going to go by the BO3. Do I write ones? So what's the final formula?
LIBO.
What?
LIBO.
No. No. Because what did you do? You changed the group. It was LiBO3. Why would we not put the 3 down there? The group has to stay. That is borate, BO3. We don't ever change the group. You don't drop the 3 because you don't like it. You leave it. Okay? So we don't ever change the group. Questions? Yes, Joshua.
Borate was BO3 and the -3.
Borate was BO3 and the -3? Wow, Isaiah.
See, I was wrong.
Yeah, you were. You still dropped the 3. But I appreciate the confidence of being wrong, Declan. So what do we do to this formula now, ladies and gentlemen? Add the 3 after the Li. That's all we need to do here. But that is why it's important that you get the proper charge for things. Otherwise, you are going to get a wrong formula, ladies and gentlemen. Questions? So does everybody understand why we had to make that change? All right. Strontium hydroxide. Strontium hydroxide. Joshua, strontium. What's the symbol and the charge?
SR1 or SR +1.
Sure about that?
SR +2.
Thank you. Okay. Again, we got to make sure we get charges right, ladies and gentlemen. Otherwise, when we balance it off, we are not going to get a correct answer. All right. Hydroxide, Joshua. -1 charge. Good. So again, the -1 is going to go down by the strontium. The +2 is going to come down by the OH. So Joshua, what would our formula be?
SR parentheses OH2.
Perfect. SR, OH in parentheses and a 2 by it to balance it off. Questions? Okay. Ammonium sulfide. Ammonium sulfide. What would that one look like, Mason? Ammonium, let's start there. Oops, my bad. I wrote that wrong. NH4 +1. All right, sulfide. What does that come from, Mason?
Sulfur, which is -2.
Good. Thank you. Remember, sulfide comes from sulfur. Okay? It's not a polyatomic. It's not sulfate. Okay? So again, it is possible that your ending could be IDE and it end with a lone element like we're doing here. So this 2, ladies and gentlemen, needs to go down by the NH4. This 1 needs to come down by the S. So Mason, what would our formula be?
NaH4 in parentheses 2S.
Perfect. There you go. Questions? Any at all? Okay. Let's do magnesium carbonate. Okay. So, Michaela Powers. Magnesium. Symbol and charge, please.
Mg charge +2.
Okay. Carbonate. Formula and charge. I say formula because we know it's polyatomic. It ends in ATE.
CO3 +3.
What's the charge?
-2.
-2. Okay. So this 2 is going to come down by the Mg. This 2 is going to go down by the CO3. So what would our formula be, Michaela?
Mg2 in parentheses CO3 out of parentheses 2.
Okay. Are we good? Mason shaking his head no. Mason, why are you shaking your head no? Okay, what you did was correct so far, Michaela. Perfect. We did the crisscross method. But we did end up with a 2 here and a 2 here. And we can do what to those? We can reduce them, cancel them, however you want to say it. That's fine. You do need to still reduce these. And you can reduce this compound by 2 because of the fact that there's a 2 here, and it is the number outside of the parentheses only. We do not do anything to the ones inside, only the number outside. So we end up with MgCO3. That is the only place where the crisscross method lets you down, is you have to double check and make sure that we cannot reduce our subscripts. Questions? Yes, Michaela.
For lithium borate,
Yes.
does that like not count because it was like the borate? Or, like,
Okay. 2 things. Good question. Number 1. 3 and 3 here, right? Okay. Rule number 1. We never change this group. BO3. What number is by the B, by the way?
No.
Which makes it? If there's no number, what is it? There's 1 of them there. So we can't reduce it anyway, because we would have to reduce the B as well as the O. Okay? But we never do that because this is a polyatomic. We never change that group. Okay? I'm glad you looked at that. I'm glad you saw that. But remember, these are 2 different elements making up this compound. So because of that, we can't reduce this anyway. Okay? And even if this were 3 and 3, we never change polyatomics. So if the polyatomic happened to be B3O3, we couldn't do anything with it anyway. It has to be written that way. Okay? So it's only the numbers that are outside of the parentheses that we look and we see if we can reduce. Fair enough? Questions? Yes, no, maybe so. All right. All right. Then, ladies and gentlemen, in your notes, we left off here, ladies and gentlemen. So please open up your notes. Open it up to slide number 25, please. You can stay where you're at. We're going to be going back there in a minute. Grab your computer. Not a problem. Okay? You're going to be working with that person again in a few minutes. All right. So again, ladies and gentlemen, this one is very similar to the one we just did. When we do the crisscross method, we are going to get GA with a -3 by it. Now, I know we don't have to write the negatives. We don't have to write the positives. Okay? And if you're getting to the point where you can do the crisscross method without writing those negatives and positives, that is great. If not, you're going to still have to do it and then take them away. I don't care. Okay? But when we do it, ladies and gentlemen, we put a -3 by the GA and a +3 by the PO4. Now, here is a case again where you have a 3 and a 3. So what can we do to these, ladies and gentlemen? We can reduce them. So in the end, they reduce down to a 1 and a 1. Now, because I'm not putting a 1 by the PO4, I take out the parentheses. This is the reduced version of this formula. 3 and 3 get reduced down to 1 and 1. With the 1 here, I do not need the parentheses. If you write parentheses when they are not necessary, it will be incorrect. Questions? Okay. So, now we're going to write the name of a compound. Okay? You write the name of the cation. You write the name of the anion. You do not change the ending of the name if it's a polyatomic. If it is a polyatomic at the end, you do not change the ending of the name. Whatever the name ends in, you write it that way. However, if it is a single atom, if it is a fluorine, a chlorine, an oxygen, a nitrogen, a sulfur, a phosphorus, we will still put those ending in IDE. Now, the only time that would happen is if what is your cation? Ammonium. Ammonium. That's the only one I will give you. Okay? That is the only one that's on the back of the sheet. There are other ones that are polyatomics that are positive, but we will not be doing it. Declan, you can close that computer and you can go sit outside if you want. But right now, you're not only distracting yourself, but the person behind you. So stop it. I don't know what you're doing, but stop it. Okay? Thank you. So we name this, ladies and gentlemen. Mg is magnesium. NO3 is nitrate. That is it. We're done. Name the cation magnesium. Name the anion nitrate. You are finished. Questions? If you want to participate in class by writing this down, Declan, you can open your computer up. If you want to do little videos or whatever, you can leave it shut. I don't care. So again, our endings can be very easy in this. If you end with a polyatomic, which is what most of them will do, you just name that polyatomic. Okay? You just name that polyatomic. Questions? Anyone need more time with this one? All right. So write the name of the cation. In this compound, what is the cation? Ammonium, NH4. It's at the beginning. Why? Because there is no anion H4Cl. You won't find it if you look on the back. Okay? So, ammonium, NH4. What's the anion in this case? The negative ion. Chlorine, which becomes chloride. Ammonium chloride is your compound, ladies and gentlemen. Now, this does end in IDE. Yes, sir. I don't know. I didn't think we got to this on Friday, but we might have.
Next one is lead 4 sulfate.
Okay. Okay. Then we got further than I thought. Thank you. Anyone need more time? Okay. Did we do this last week, ladies and gentlemen? Okay. What is the one thing about this one that we have to be careful of?
The light charge.
What do you mean?
It need to be 2 or 4.
Okay, so for this one, we would need a Roman numeral in the name. Okay? We would need a Roman numeral in the name. All right? For us to do that again, ladies and gentlemen, for us to do a Roman numeral in the name, we need to be careful. Okay? We need to undo this compound. What I mean by that, ladies and gentlemen, SO4, what is the charge on SO4 always? What is always the charge on SO4? Somebody, please. What is it? Look on the back of your sheet, please. -2. Okay. Now, how many of them are there? How many SO4 groups are there in this compound? There are 2 of them. That means that that total charge is a what? -4. That means that this lead, ladies and gentlemen, this lead has to have a total charge of what? +4 to balance off the -4. Okay? How many leads are in this compound? There is 1. So what has to be the charge of it? Has to be a +4. Has to be a +4. Okay? So we have to work backwards to find the charge. And when we do, ladies and gentlemen, lead 4 sulfate. Questions? Yes, no, maybe so. All right, write me names for these 4 compounds. Go, ladies and gentlemen.
What's the first one?
What do you mean?
Your little message up there is blocking on it.
Oh, sorry. Let's see if I can. There you go. Okay, I guess I can do that if I need to. Good to know. Good to know. You can't find something, if you need help, please raise your hand. I will be happy to come around and assist you. Oh, Michaela. Grab your periodic table and a calculator, and let's go and finish this up. It's all set for you. Okay, good luck. GANO3 in parentheses 3. Keanu, what do you got? Gallium nitrate. Very good. Perfect. Okay. K3PO4. Lucy, what do you got? Perfect. Potassium phosphate. Good. Okay. SR3 ASO4 in parentheses 2. Jaden, what do you got? Strontium. There we go. I'm sorry, what was the last part? Arsenate. Very good. Strontium arsenate. All right. CaCr2O7. Anthony. Okay, well, what's Ca? Okay. So now turn your periodic table over on the back and find Cr2O7. Okay. Dichromate. Way to work well under pressure, sir. Good job. There you go. Now, it is harder to write the formulas than it is to write the names. And here's what I'm going to tell you. Half of your test is going to be writing formulas and half is going to be writing names. Do well on the names part. That way, if you occasionally mess up on a formula, well, okay, don't miss the names, though. The names are the easy part. Questions? Ternary ionic compounds, ladies and gentlemen. Go to work with a partner. Go to work with a group. You can go back to the lab station and put 4 people in a lab station working on it together. You can pull desks together if you want. Do what you need to do, but let's go get into work on this worksheet, ladies and gentlemen. I get you for about the last 7 minutes of class. Okay? So you've got until about 33, 34. Then I get you because I want to talk to you about something else.
Actually, no, it was stated in the ternary one, a group of atoms, covalent means a bonded together acting as a single ion. It is on slide.
Oh, I remember that.
You going to the Halloween party tonight?
If you need more scratch paper, ladies and gentlemen, I have tons up here. Come up and get a full sheet, a half sheet, whatever you need.
How'd you get that?
I know how I did that. Yeah, they
Oh, that is.
I knew that. I tried Morgan.
I don't know how I got to it.
I don't know, what are you talking about? Oh, right, that's I
Okay.
It's a question.
Are you asking?
No.
Ternary ionic compound. Oh my god. That is like, hold on, I'm not there yet. We did.
Really? You two get along well.
Absolutely judge.
Who was the jury in the execution?
No, our judge was
Lawyer. No, that's illegal. That's illegal. Lawyer. So it's not even called.
I went,
no, that's shy.
That's what I meant.
Why did you put
Oh. There's so many questions.
Now we still
What do
have.
you mean there's so many questions? Yeah. Bro. Yeah. Bro. What is what? I don't understand. Oh, I was thinking it was. Oh, what? I was straight through the notes. She has the proof. You just. I'd rather have. I know how to do it. I did. Yes, it's the district. I'm not going to fight it. My brother and I were singing that. Oh, that's it's cute. Why are we?
You could also highlight it. Oh, you what?
Okay, to get the little subscript down below,
Oh, yeah.
control of the comma key, type what you want, or highlight it when it's in there. So, like you can put a regular size 2 in there, highlight it, hit control of the comma key, it'll make it into a subscript.
I don't know. I don't remember any of this.
Bro, he's not great at that. Well, here's the thing. On a test, you're going to be writing.
Exactly.
You're not going to be typing. That's why it was. There's not a program. Well, there we go. It's hard to do.
Which one? Which one are you writing?
Yeah.
So writing something out.
Getting to the top of it. Well, you can tell that.
Well, if you want to put a number by it, you still need to put it in parentheses.
Because we never want to change the group. So anytime we are putting a subscript by a property topic, we put it in parentheses. Even if there's no number that it ends with. So like PO4, it looks unusual to put PO4 too. Just put 42 boxes. But like CN, yes, you still need to put it in parentheses. By the way, ladies and gentlemen, I have highlighters up here. If you want to highlight cyanide and hydroxide on the back of your periodic table as the two polyatomics that still end in IDE, might not be a bad idea for you.
There's two other ones that end in ID. I don't know how to say them. But
Oh, the ferrocyanide, ferric cyanide, and ferrocyanide. Yes, you could highlight those as well.
No.
As the ones that will end in IDE, even though they are a binary compound, or polyatomic ions.
Not my problem.
yes, it is. We started it.
Yep. But we still do it the same way we look. What I mean by that is
Good job.
four, right?
Highlight.
What's one?
Highlight.
What's the one that is?
You highlighted.
It's not a highlight. It's not a highlight. It's a board.
You highlighted it. So it doesn't matter.
But if I need to put a number down by one, I'll put it in.
It's supposed to stick out. I don't know how to talk about it. Probably crazy with potato salad. Every day, that's something that we do.
Yep. So you can take two polyatomic ions and mix them together. The way we do it doesn't change. The way we do it doesn't change. Yes.
I'm not going there. I'm not going there. I know better than to go there. Oh my God. Oh. Hey. No. I'm about to say something.
Yeah, those are all I looked at it. It's great, man.
If you need to make your font in the boxes smaller so that they fit the entire formulas, you are welcome to do so. You can do that.
Or first. There's a lot of
This is way. Why do you want it? Why do you want it? This is why you got here. That. Why? Bro. We know. I'm on the first section. What? Is that it? We have to be here so.
We got her? Thank you.
They just said this is
Thank you, Michaela.
Right.
I like that. Crazy.
Oh yeah, no, you said I was like this far from your face. Like,
Keep working, ladies and gentlemen. I will take what I was going to talk to you about at the end of the hour and do it to start the hour tomorrow. Better to do it that way.
Oh, so
I'm gonna ask if I can.
Change the time. Like I do every other time, you have to send me an email.
He hasn't said it. He hasn't announced that. He doesn't. It's like tickets are gonna go. What? Which one?
Morgan's
No way.
We started. We started.
Well, it is due tomorrow by the end of the day. So tomorrow we are going to introduce another piece to this, and then I will give you time to work on more.
No, because I'm constantly outnumbered.
What do you mean by that? Adam's racist.
Yes. What's it? Hang on until someone turns one in, and then you can grab it from them. Okay. Josh, are you done with your charger? Can you give it to Michaela?
When I was like 6.
Oh, just you calm down, friend. You have ears.
It's super grown up.
You have ears. Look at ears. I don't know.
you're gonna have an engineer.
Why would you throw back into the way?
Do you know why we're on that? Are you talking to me? Why?
Number one, my father.
You said it's
Second hour game,
I remember this day in the air, and I was just like, this might happen.
They could be like, bro, what did I spill on this book? And why does everyone happen? Or you like this? Alright guys, we're on it.
I was sitting right next to you.